This is a production of Cornell University.
Thank you very much. Andy, is my mic working? I guess so. Thanks a lot, Andy. It's a pleasure to be here for many reasons, because Andy is a very, very good friend, and I missed him when he left CIMMYT for Cornell. I was a bit upset about Cornell, of course, recruiting him. But I think it's also because I know Cornell for a long time, and that's my first visit ever. So I think it's a pleasure to be here. I know Cornell by reputation, by its good reputation, by the publications, and by many colleagues who graduated from Cornell and who have worked in the CG or still working in the CG system. So many thanks to be so numerous here today. When I give a seminar in CIMMYT, you have usually smaller rooms, so it's great. I will try to give you an overview of the work we do in CIMMYT through the lens of mechanization. And it's a presentation I made for the board. We are board of trustees. You know, I want to know a bit more about our programs, and they usually want to have something on mechanization. I say, not again mechanization. So this presentation is not about mechanization. It's the lens of mechanization and sustainable intensification through the lens of mechanization. Before I start, I have a couple of slides about the CGIAR research centers. And how many of you heard about the CG? So I don't need to explain very long. So the CG was created at the end of the 60s, beginning of the 70s, as a body of centers. I think initially there were just few centers. CIMMYT is one of the oldest one. We just celebrated our 50th anniversary not so long ago, 2 years ago, with the mandate to look at research for development or research in development. So the CG was created with, now we have about 15 centers. A lot of changes that will happen in the next 2 years, and I don't want to go into that because it's still a big interrogation mark. How the CG will be shaped in 2 years' time. But it was created just to cover most of the developing countries, both in terms of geographies and also in terms of thematics. So CIMMYT is the center working on maize and wheat. So it's known as International Maize and Wheat Improvement Center. We do much more than breeding, because we are still very well known by a breeding component, but we do much more than breeding. And we are also, I heard about the CRP, the CGIAR research programs. Much less, it's not as popular. That was the last reform of the CG that was about 9 years ago. So research programs were created, and there are about 15 research programs. We are leading 2 research programs, one on maize, one on wheat. We are also leading a platform, which is something a bit different than a program, and it's newer, the Excellence in Breeding. And we are part of the Agriculture for Nutrition and Health, that's led by IFPRI, and also by the CCAF, the Climate Change CRP, which is led by CIAT. We're also contributing to the Big Data Platform, to the Gene Bank Platform, and to the PIM, the Policy Institutions and Markets. So those efforts are made for us to work better together as a body of centers. Let's go back to sustainability intensification through the lens of mechanization. And I thought that my presentation to the board would be boring. And I really got excited the more I thought about that. And the more I developed my slides, I thought, well, that's a really nice exercise just to take something as, you know, narrow as mechanization and just look at its impact in the system. So the key messages. We are probably by far the center having the largest portfolio on mechanization. IFPRI has worked a bit on mechanization, but mostly on the policy issue. We work in Asia, Africa, and Latin America, and that's, you know, CIMMYT has offices in several countries, and we are covering our regions as Latin America, but mainly in Mexico, but also Sub-Saharan Africa, mostly Eastern and Southern Africa, and then South Asia, where we have the largest portfolio in our program. And that's thanks to Andy, who developed that portfolio in a very efficient manner. So we have a long history, especially in South Asia, and I think Peter Hobbs is maybe here. Peter, are you there? Yeah, Peter is there, and I think it's one of the pioneers. He was involved in conservation agriculture and in mechanization work, because I mean, those two are very much linked. I mean, that's one of the challenge of conservation agriculture is linked to mechanization. And there was, previous to the CRPs, there was several eco-regional programs, and the Rice Wheat Consortium was one. And that, I think, was very efficient. I mean, I joined CIMMYT after that program, that consortium was closed, but I think it was very, very efficient, and that was the foundation for our work in South Asia. And we work with IFPRI and IRRI there, and IRRI, the Rice Research Institution. So our work on mechanization is broader than engineering. So it's a systemic approach to mechanization. In fact, we don't have many engineers. There's a strong potential contribution of mechanization to sustainable intensification in smallholder farming systems. The contribution of mechanization to social inclusion is also very promising, and I show a few slides about that. The effective ways to scale mechanization is through public-private partnership, commercialization, creation of business opportunities for service provision. And I have a few slides about that as well, because we just don't want to do research. We want to have research at the end with an impact on the ground on the largest number of smallholder farmers possible. So there's a strong policy dimension, and I will just show you also a few slides linked to the policy dimension. So where do we work on mechanization? We have a large flagship program in Mexico called Masagro, and we have a strong mechanization component there. We work with ICARDA, which is another CG center in northern Africa on rain-fed wheat systems and the wheat CRP initiative. We work in East and Southern Africa, and we have different funding there with good funding from the Australian ACIR, which is the FACASI project. We are funded by the Germans as well, with some interest in mechanization, that's GIZ. And we are linking with FAO on a project in Zambia, funded by the European Union. So the largest, in our program, the largest portfolio is in South Asia. It's about 50% of our funding. And there we work under the CISA portfolio. It's a series of projects, all connected, under the wheat CRP and also under the Borlaug Institute for South Asia, which is a structure that was created by CIBIT to work in India. And again, Australian funding on the surface area project. So we have a diversity of geographies where we work, very different biophysical, but also some socioeconomic environments. CG centers are supposed to work above the national level or the local level. So that's the richness of what we do, and that's probably what we can bring to national programs, because we work a lot with national research programs and development structuring countries. So you can imagine that's three landscapes. The first one is a very, very large field. The second one is a very fragmented landscape in Bangladesh. And the other one is a landscape in Kenya. So the second one is mostly rice-based systems. The one in Kenya is mostly maize-based systems. So you can imagine that with such a diversity in field size, mechanization solution might be quite different. Opportunities and constraints to adoption of mechanization can be quite different. So trying to find scale-appropriate tools to work on the different landscape is one of the objective of our research. There was large efforts in pushing mechanization in the 70s, 80s in Africa, and that was a major failure. I remember when I worked in Niger in the early 90s, I think the average lifespan of a tractor was below 100 hours. And that was just state schemes. That was funded mostly by the World Bank, I believe, and it was a complete failure. So for a moment, I mean, the thing is that in the work we do, sometimes people judge. It doesn't work. They don't look at why it didn't work. It doesn't work, so we don't look at it anymore. So we had about, in Africa, about 8-9 years ago, we wanted just to look at opportunities for mechanization because we could see that the adoption of mechanization in South Asia for smallholder farming systems was something very interesting. So large-scale mechanization and conservation agriculture. One good thing about conservation agriculture is that you don't need to have primary tillage. That means that you can work with less horsepower than smaller tractors. That's the big advantage. We're also looking at mechanization with the minimum negative social and environmental consequences. So in terms of the need for land consolidation if you have large mechanization schemes, or the labor displacement and the soil degradation, which is a major focus of our research as well, and our focus on conservation agriculture in our program. So machines should adapt to farm size and not the opposite. I think it seems quite obvious, but sometimes you still see schemes in Africa where people are coming with large tractor. I went to John Deere a few years ago, close to Chicago, and to the headquarters. And they didn't like what I was presenting because their business is to sell the largest tractor possible. So they didn't like conservation agriculture very much. So in the context of sustainable intensification, we will look at the impact of mechanization on different things. The most obvious one is labor is a major limiting factor to productivity of smallholder systems. And there are key times in cropping systems or farming systems where labor is really missing and have a negative impact on yields. So you can see two of the publications from our group related to that. And I can give, the list of publications. I've cited it, and the presentation will be or can be circulated as well. It's nothing secret there. Crop establishment is the most critical time of the year, and that's valid also in South Asia in irrigated systems. So it's not only water, but what you can see there is a 7-day difference. You have maize on the left side, maize on the right side. 7 days delay can have a dramatic effect on yield. So you can see that cloud of points, and that's for South Asia. So a delay in sowing dates and impact on wheat yield in BR. The reason there is not like in rain-fed system. It's more like the terminal heat stress you can have on wheat if you plant too late. The wheat in the Indo-Gangetic plains, there are 2 seasons, a cold season and a monsoon. The wheat is grown during the cold season. But at the end of the wheat cycle, temperature is increasing. So you have terminal heat stress and having a large impact on wheat yields. So crop establishment is also very demanding. And that's, you can see the work that's done here in Ethiopia with a pair of oxen. And that's classical tillage. And you can see the amount of soil movement done by those ladies in East Africa. So one thing that's important in mechanization, planting, seeding. And one of the challenge with the equipment for under conservation agriculture and mulch is to go through the mulch. So that's one of the work we do, is trying to find the best or develop the best planters that can go through the amount of crop residue left on the field. And we have solutions. We have 4-wheel tractor solutions. We have 2-wheel tractor solutions, depending on the area where we work. So that's the work on mechanization. Some of the labor measures done in East Africa. You can see that the conventional establishment It's requiring quite a lot of hours, and the mechanized CA is just much reduced. So it's a major impact on labor, and that means that you don't have to work 2 or 3 weeks to establish all your fields. You can work much faster, and then you have an impact on yield as well. So that's all the different operations, and the classical time. What's taking the most time is the planting. So you have the manual, and you have the mechanized options. Mechanization and water. Water is also an important input in most all the farming systems where we work. Major impact has been done on working on laser land leveling in India over the last 20 years, I think. Peter, when did that start? The land.
I started in Pakistan probably in the 80s.
80s, huh? So, of course, as CIMMYT, we didn't create the technology. Laser land leveling was existing and was used in US quite intensively in places like Utah. But we worked with national partners, and we developed, schemes for laser land leveling, having a major impact on water management in those systems. So I think right now in India, I think there's about 6 million hectares. They've been laser land level, and of course, time to time, you need to re-level your field. So there's a good business around that. We are working more on technology of tomorrow. I mean, we are just developing some, or doing some research on subsurface drip irrigation, and we get fantastic water use efficiencies under those systems, plus the option of control much better the fertilizer input through fertigation. So we have some work there. The slide on the bottom left is about axial flow pumps that can be paired with the PTO of a two-wheel tractor. So that means that if you don't have too much, of course, that's suction. Those your lift cannot be that large. But in Bangladesh, you can usually find open water and bring it to your fields. So that's also a very interesting option for farmers for supplemental irrigation. And we have mechanized also, and that's a prototype that's been developed at the BISA station to lay down drip lines under the surface. The good thing with minimum tillage or reduced tillage or no tillage is that you can put your lines down and you don't need to remove them at the end of the season. So it's if you don't have too much rodents around, you can probably keep your lines a few years. So impact at scale, that's the figures I was talking about on laser leveling. So you have now 40,000 units in India, and was mainly done through private investment and service provision. So that can be a good model for developing and scaling mechanization in other parts of the world as well. So you can see all the figures, just impact on water management, water savings, on yields, on employment, on electricity savings. One of the issues in India is that water is subsidized. I mean, pumping is not costing. Electricity is subsidized for pumping. So it's a bit of a problem when you want to incentivize. Things that are free are just usually abused. So there are some research that's linking that to the policy, the policy component. Mechanization and nutrient use, plant nutrient use. So mechanization is obviously improving directly two of the 4R principles: the right rate. I mean, if you have fertilizer application with your planter or your direct drill seeder, and the right place as well. So place and rate, and you increase profitability and you reduce also greenhouse gas emission and nitrate leaching, which is a major problem in many systems where we work. Social inclusion, those are data from our project in Africa, East and Southern Africa. And that shows over the year the access to mechanization. And we are just monitoring. I mean, it's very important now. Our donors are not interested in publications most of the time. They're interested in the impact we can generate, either directly or indirectly. So that's part of the monitoring we have done. Mechanization in Africa, sub-Saharan Africa, is still a big challenge for many reasons. But I mean, we want to continue to work on that. So on the equity issue, who has access to mechanization is also a very important question. And then you look at the investment costs for a large tractor, and you look at the investment costs for the animal traction and two-wheel tractors. The problem with animal traction is that you usually use your animals for 1, 2, 3 weeks during the year, and the rest of the year you have to feed those animals with crop residues and feed. So one of the issues of conservation agriculture adoption in Africa is also the trade-off between crop residue use. So going to a mechanized option, a fully mechanized option, and not going through animal traction is probably much more promising. Although, I mean, animal traction might look very romantic, but it's not the best use of resources in smallholder farming systems. So again, the cost when you go from conventional practices with four-wheel tractors to two-wheel tractors, conservation agriculture, the cost is much lower. And you have again in the middle the cost of animal traction when you have to, take care of your animals between two seasons. Youth, I mean, that was a big topic in the CG a few years ago. How can we make agriculture attractive for young people in developing countries? I think we have all the same problem. I think agriculture is not very sexy in Europe. It's not very sexy in the US, but we have a lot of consolidation. In developing countries, in many places, that's the only livelihood option for people. And you have a lot of migrations to cities and so on. So population is often aging very quickly in smallholder systems in Asia and in Africa. So that's an example where you had a maize sheller, which in one season generated $6,700, which from our standard might not look very big, but it's very big in Africa. It's a large amount of money. So we are looking also on on those service provision and how long it takes to return to have the return on investment, and usually it's quite short. Gender impact. That's a very simple sheller again, but there was a huge reduction in labor demand and drudgery for that. It went from 12 days per ton to 1 hour per ton. That's all those systems. So it's this is Africa. This is the work in Bangladesh, and again we are monitoring and we are looking at the impact of mechanization on different important livelihood components. Childcare activities, cooking, our farm labor, livestock, poultry, income generation. So the time you free on your operations through mechanization, you can invest it in income generating activities. Harvesting, carrying, threshing, help to manage farm laborers. Time spent on leisure. Life in small farms in developing countries can be tough. This is something that's very, I think, profitable for people as well. That's linked to the drudgery, and there is a strong gender dimension to that as well. I think usually women work many more hours in rural landscapes in Africa, in Asia than men. Time sleeping as well. Sleeping is important. So it's an interesting study showing the just the implication of one mechanization option, which is the reaper harvester. So how do we scale that? The question is that in Asia, it's already a large adoption of mechanization options. In Africa, it's just at the beginning. So we are looking at model to scale out appropriate mechanization. And one key thing is service provision commercialization. So professionalization of the activity. We don't dream about every farmer having a small two-wheel tractors. I think the service provision is much more efficient. So that's the classical adoption, technology adoption curve. And I would say that in Africa, we are about there. I think in some places in Asia, we are there. And the research questions are still very interesting, even with adoption at scale. That's a very interesting aspect. So being able to work under that adoption, technology adoption continuum is also very interesting for us, and learning also from what we do in Asia for the future in Africa. That's one of the projects we have in Bangladesh, and that shows the growth since the beginning of the project on machinery service provision. So again, that's part of the monitoring and evaluation. That's a USAID, that's a US funded project, USAID. And it's very important that we document also. Those are the achievements after the phase one of the project. And we are now going into a phase two, which is a bit different and has been redesigned. But those are not small numbers. They are large numbers. And I mean, we are pretty proud of that. So we are not a pure research institution. We are, at the end, working for impact on the ground. So a lot of work has been done in Bangladesh and in other places as well to look at the best business models for scaling mechanization, increasing adoption of mechanization options. And we have even a scaling specialist now in CIMIT, we call it like that, looking, among other things, at mechanization options in different systems. So that's a slide where you see my favorite US president on the left side. And that guy is Jill Oliver. He's a kind of innovator, and he is a Cornell grad, so you know him very well. And we are trying to work with him. So it's, you know, digital agriculture. There's also options on service provision through cell phones and so on. So it's very exciting type of work. He calls it the Uber for tractors. And that's also a great tool to monitor, you know, the work of equipments in the field and so on. Indians have their own system, which is very similar. And there are some manufacturers now that, you know, working on the scaling of monitoring systems and service provision and command systems for tools. FAO is a big player. That's the new Director General of FAO, who visited us before being elected. He was campaigning in Mexico. So we're discussing. China is an interesting country because this is probably the country where the largest number of manufacturers of two-wheel tractors, small implements, and so on. So it's a great place to go and shop. So the business models we are looking at, of course, looking at service provision, but it's not good enough. I mean, you need to create a market, you need to create import schemes, you need to train people in local workshops to, you know, develop or repair the equipment. So it's and FAO is well implemented in that regard. So working with FAO in mechanization makes a lot of sense. Information, knowledge, communication is also very important. And I think we have done quite interesting videos, especially in South Asia, I guess. How many videos do we have, Andy, related to mechanization? Quite a few, no? Yeah, so, and we have briefs and we have a lot of things. Capacity development, and we are running conservation agriculture training courses at least once a year in Mexico and once a year in South Asia. So it's also very important to enhance, you know, capabilities in different countries where we work. So I was I was teased by the top management of CIMIN. They say, you do interesting work in mechanization and it's not visible. And sometimes people don't see what they don't want to see. But so we've done a specific efforts in trying to brand our work also for different reasons. I mean, for people being interested by the topic, from other research or development organizations, for fundraising. I mean, we work only on soft funding, so we have to we have to raise money for the work we want to do. But there's been a lot of tweets and discussion while we are using Twitter, we are using Facebook, we are using different tools. One interesting aspect related to mechanization is, and you probably heard about the air pollution problem in Northwest India, in Delhi, which is not only due to crop residue burning, but crop residue burning is adding a layer of pollution at the time of rice harvesting, which is in November. And rice residues are burned not just because farmers like to burn things, it's because they have to prepare the land for the wheat, subsequent wheat crop. So the time is not that big, and that's one of the first slides I showed, the penalty, the yield penalty you have on wheat by delaying your wheat planting. So the easiest way to get rid of crop residue is just to burn it. So we've been looking for a long time. I think, Peter, the first version of the apiceder was developed when? That was Australian funding, initially.
New Zealand.
Blackwell.
It was actually UK funding.
Yeah, and that was in
1980s.
Yeah, okay. So the thing is also, that's the message, you know, long-term investment pay. I mean, some donors are getting very impatient. You know, they write a project in 3 years, you have to have, or 4 years, you have to have impact at scale. It doesn't work like that, I think. Sustained investment and coherence in what you do over the long term is very important. So I'll just show you, that's a combine harvester harvesting the rice on the left side and directly planting the wheat just after harvesting the rice. So it's just fantastic. So you can see the amount of residue you have and how the apiceder is working. What you can see there also, that's added to the combine harvester, is a straw management system, which is spreading the straw more evenly, that you don't have piles of straw and that your seeder works better. Another paper, interesting paper, was trying to show, and that's more on the policy issues, showing the trade-off that you can have on different things in a system. So the effect of, and I think that was in 2008, Andy, that the Water Act was taken, in fact, to save water. They just delay the planting dates for the authorized planting dates for rice. And that, of course, had a major impact on the way farmers had to manage their residue. They didn't have much time. So this paper is quite interesting because it's showing, in fact, the difference that you have in terms of crop residue burning and air pollution before the Water Act and after the Water Act. And of course, Andy is one of the lead author of that publication. So health issues are taken seriously in India as well. So I think it's, if you look in the news, both national and international news, crop residue burning is a burning issue in South Asia and especially in India. And you could see that the quick scaling of apiceders in 2 states of India, Northwest India, Punjab and Haryana, between 2010 to 2018. And of course, there were subsidies to manufacturers and to service providers to purchase the equipment. So it's not always, you know, without subsidies wouldn't have been possible, because the apiceder is quite an expensive piece of equipment, and it's just used 2-3 weeks a year. So that's so now, right now, what we are doing, we are monitoring, and Andy's still working on those topics. We are monitoring, in fact, the evolution of crop residue burning in that region. So the way forward for us, I think we have increased the visibility of our work. I mean, again, visibility is important if we want to sustain and continue to have funding for that type of work. The scaling work as well. I think our role has been a knowledge broker through systemic approach. So we are not just narrowly looking at engineering. We want to keep strong linkages between mechanization and more sustainable agricultural practices. And it's a natural match. If you look at conservation, agriculture, and mechanization, it's a natural match. We want to enhance gender youth relevant technical innovations and the scaling. And that's not only for field operation, it's also post-harvest and transport. We want to explore new regions. I think we have been discussing in West Africa with Benin, with the Minister of Agriculture. Strong interest from Rwanda as well to have a mechanization program developed in that country. Southeast Asia, we are not very present in Southeast Asia. I mean, we are almost absent in Southeast Asia, and we are looking at opportunities to work there as well. And we want to develop also South-South collaboration, China, Africa, India, Africa, and public-private partnership approaches. India has fantastic engineers in Punjab, and I think it can really serve Africa. So it could be win-win solutions, options in terms of business development, in terms of benefits for smallholder farmers in Africa. So we want to keep our key collaboration developed further with FAO and the GIZ mechanization platform. So right now in the CG, we are reinventing ourselves, and we are wondering whether we should have an initiative on mechanization or not. It's not yet proposed, I think, but it could be something where I think all CG centers would be interested in working on a systemic approach to mechanization. So thank you. So I hope I didn't monitor the time. I was not too long. Huh? Okay.
Questions. The floor is open.
Bruno, thank you very much for your talk. Peter had to leave a little bit early, but he asked me to ask you, if you are a smallholder without a lot of resources, how do you actually gain access to some of this mechanization? What's the actual procedure for being able to do that?
Well, there are places where there's no access yet. I think it's developing business models, which would involve probably financial schemes, would involve public and private sector. So in India, it's flying. I mean, it's not that difficult. In Bangladesh, there's a lot of momentum around that as well. In Africa, we have to prime the pump because there's nothing. And so our research in the FACASI project was more a discovery phase on mechanization options using two-wheel tractors. And we see, I mean, you have seen the figures in terms of cost, timing, yields. I mean, it's a no-brainer when you see that. But now the challenge is to build an ecosystem around mechanization in Africa. And I think that's what that's what we want to do. Because new research questions will emerge when you start having adoption of those technologies. Another thing is, and I didn't present it here, but it's the targeting. You know, what are the low-hanging fruits when it comes to where to put mechanization, where to start it? We need to initiate that somewhere, and it's not in the middle of the bush probably. You know, proximity to cities is important. Having farmers who are more aware of, you know, more eager to mechanize also. So it's a range of criteria on where we should start. And we are looking for, you know, government support as well in doing that. So we are not working alone. We work with advanced research institutions, but also with national research organizations, NGOs in some cases. In Bangladesh, we work with quite a lot with IDE. So there's not an easy option for that, but I think it's it's really context specific, and now we want to how we can scale that. But we don't have impact at scale in Africa yet. But we want to have it. So. Yeah.
Is the model more for farmers themselves to mechanize, or is the model more for a custom, that is a sector that provides the mechanization? You showed the laser leveling, which obviously has to be on the commercial sector, but I'm also thinking of planting and harvesting. Even in the United States, there's a lot of custom plowing, custom harvesting, yep. Even with farmers with a lot of possibility they could invest, but instead it's more efficient for a sector to arise. And so where is your emphasis there, or to both models that you think would apply in different countries?
We are for service provision, and in most cases, those are farmers becoming service providers. I mean, we saw that in Europe as well. I mean,
yeah.
No point in buying a large combine harvester if you have 50 hectares of wheat. I mean, this doesn't make sense. And for most systems, it's like that as well. So we are trying to provide incentives or, and knowledge for investment in terms of service provision. So you saw the youth group, they are rural youth, and they just invested in the thing, and they will probably help in buying, the maize sheller, but they paid it back very, very quickly. So it's those type of things, positive deviance in the way of working in landscape will incentivize other, but you need a critical mass. I mean, you cannot just have one, mechanized service provider somewhere, because that guy will not be, welding to get equipment, will not be welding to get repairs and things like that. So it's a full system that we need to develop. And I believe that the learning from South Asia, India, but also Bangladesh, where farms are much smaller than even in Africa, can be very useful for developing schemes for Africa.
Thank you.
Yes.
Over here.
When you gave your talk, your example about the livestock, going away from the livestock, and then you have to feed them for the rest of the year. But what about all the fertilizers and other things? You didn't count?
Yeah.
Discouraging.
No. I worked for the Livestock Research Institute before. I don't say get rid of the livestock. Don't use livestock for powering your operations in a farm, because usually those are, in Ethiopia, for example, a pair of oxen, they are not used for milk production when at the end of their life, and maybe a bit of meat, but they are eating a lot for non-productive function except operations in the field. So if you look at the economics, it's better to invest in dairy cattle than in cattle for animal traction. So that's my point. I don't say to get rid of the, don't get rid of the livestock.
I just mean that you could go to a tractor from using animals.
Yeah.
You also don't get any more.
Yeah. Well, but you could still have livestock, but not to do your traction. Though you feed them to produce milk, which is a much more rewarding way of looking at things. Yes.
Why don't you have projects in South?
We have projects in Mexico, which is North America. We have worked in Guatemala quite a bit on milpa systems on hills. So it's mechanization was not the top priority there, because those are complex, farming systems. Milpa, which several species, slopey fields, so erosion problems, but I think very few opportunities for mechanizations in those systems. And further south, we don't have funding to work in most Latin American countries. I think it's, the funding is also the thing that's driving us where we work. It's presence of maize or wheat in systems, and then the funding we can. Yes. Oh, yeah. There was a question there for a long time. Yeah. Sorry.
Yeah, it actually riffs on a couple of things that have come up. This issue of adaptation or adoption, not adaptation, adoption of two-wheel tractors, and you gave a couple of good examples of this, or of where I'm going. One is the corn sheller, and one is the axial pumps. what other idea, I mean, from this adoption perspective, what other ideas are you following up with, or directions that you're coming up with that these two-wheel tractors can be used for co-uses that are not directly tillage type of, those would be
Transport. Transport is a big problem. I mean, if you look at market distribution in Africa, usually people have to walk a lot to access markets, both for inputs, but also for the products they want to sell. So, a two-wheel tractor with a trailer is much better than using a donkey or even using your back to transport things. So transport is a thing we are really looking at as well. Yeah.
So I have a question about the integration of mechanization. How available is fuel, and when you're thinking about adoption, are you thinking about the design and its integration into a context which might be potentially limited to fuel availability? That's an issue.
Fuel, that's your first point. Yeah. No, you have to build those systems. I mean, again, in India, it's not a problem. In Bangladesh, it's not a problem. But if you're in the middle of nowhere in a landscape in Kenya, Tanzania, or Zimbabwe, you have to develop those services as well. So it's a full ecosystem when you look at and with the data we have, we believe that it's worth investing for governments to invest in mechanization in their country. So that would be, not, I would say that would be national investment for that. So that's the type of, pledge or plea we do when we discuss with national research programs and governments on mechanization. And that's the request in Rwanda came from the Minister of Agriculture. And she said, we want CIMIC to be involved in mechanization, and we want to develop that in our country. Ethiopia is very receptive. The only problem is that sometimes people just want to take shortcuts and take the very simplistic approach. They resume mechanization to just buying equipment. If you buy equipment, you'll go back to the World Bank investment in the 80s, where you just get the thing not used and destroy in a few months. So unless you have trained people, you have workshops, you have retailers, you have the support in terms of fuel and so on, there's no point in investing. That's not the first step. The first step is not buying the equipment. That's the easiest thing to do. That's probably the thing that will not work if it's done in isolation to the rest. Yeah.
Are you seeing any opportunities for electrification? So local solar power, battery operated?
Yeah, we can. We have not looked at that in particular, but I think there are programs in India, for example, looking at, the energy approach in farming systems, and of course that's something very, very attractive. So yes, that could be part. If you look at mechanization, under that umbrella, you can put a lot of things that's linked to energy use in rural systems as well. So energy production, energy use. So it's yeah.
Okay.
I think we are out of time, so let's give Bruno.
This has been a production of Cornell University, on the web at cornell.edu.